The reason why this tomb endured and survived armies and earthquakes is the Napatans who built it cut it into the sandstone surface of the mountain. Ancient Petra, carved from solid sandstone, is one of the world's most amazing cities. The treasury and monastery rise higher than 39 meters, perfectly symmetrical, yet built without scaffolding or blueprints. How did the Nabotans achieve such precision? Could they have used lost techniques that modern engineers still cannot explain? Join us as we uncover the secrets hidden behind these stones. Petra, the city carved from stone. Petra sits in the heart of Jordan's desert, surrounded by rocky cliffs, deep canyons, and wide stretches of sand. This ancient city was the capital of the Naboteans, a people known for their trading skills and engineering talent. Petra was not just a settlement, it was a city carved entirely from rock. Entire buildings, tombs, and temples were shaped from solid sandstone cliffs, creating a landscape both beautiful and impossible to imagine. Today, Petra is a UNESCO World Heritage Site, attracting visitors from around the world. But even after centuries of study, the methods used to construct it remain a mystery. The most famous structures in Petra are the treasury and the monastery. The treasury rises 39 meters into the air and stretches more than 25 meters wide. Its surface is covered with intricate carvings, columns, and decorative figures, all cut directly into sandstone. The monastery is even larger with massive facades, towering over the surrounding cliffs. Both monuments are masterpieces of precision. Every line, every angle, and every carving seems perfectly measured. Yet, these structures were created without scaffolding, blueprints, or the ability to step back and view the work from a distance. The builders had to carve from the top down, cutting into cliffs while standing on narrow ledges. This approach would seem impossible for achieving symmetry, but Petra's monuments defy all logic. Modern scans of the treasury reveal astonishing precision. Measurements show that the facade is symmetrical to within 20 millimeters. That is the same level of accuracy, achieved today using laser-guided stone milling machines for a city carved more than 2,000 years ago without machinery or modern tools. This precision is remarkable. Engineers and architects struggle to understand how the Nabotans could have planned every detail so carefully. Scholars studying Petra have noticed that the proportions of the facades follow mathematical patterns, including the golden ratio and 3:2 ratios. This suggests that the builders had a clear design in mind before they even began carving. Adding to the mystery is the near-complete absence of inscriptions on the largest monuments. Most ancient civilizations left records of their achievements, but at Petra, the treasury and the monastery have no written markers, no names, no dates, and no explanation of their purpose. This is unusual because smaller tombs and buildings across the city do contain inscriptions, which often include dedications, trade agreements, or religious notes. The silence on Petra's grandest structures raises questions. Why would the Naboteans invest decades, or perhaps generations, into creating massive monuments and leave no record of who built them or why? The scale of Petra is staggering. The treasury alone required removing thousands of cubic meters of sandstone. Every column, arch, and decorative element was carved directly from the cliffs. Engineers today rely on cranes, scaffolding, and computer modeling to achieve such results. The Nabotans had none of these tools. The fact that they managed to create symmetrical facades and towering monuments without error is extraordinary. Their knowledge of geometry, proportion, and design had to be incredibly advanced. It is likely that they understood how to divide spaces and measure angles with precision that modern science can barely replicate without instruments. Petra's location in the desert adds another layer of difficulty. The region receives less than 4 inches of rain each year. Sandstorms, heat, and the erosion of soft sandstone would have made construction even more challenging. Despite this, the Nabotans were able to create structures that have survived for over 2,000 years, resisting natural wear, earthquakes, and human interference. The treasury and the monastery stand today as testaments to their skill. Every feature seems intentional. Every curve, edge, and depth was carefully calculated. Yet no tools or plans remain to explain how it was done. How could ancient engineers achieve such flawless design without ever stepping back to see the full structure? Could there be hidden methods behind Petra's precision that modern science cannot replicate? The impossibly perfect stonework. Petra's stonework is one of the greatest mysteries of the ancient world. The monuments, tombs, and temples carved into the cliffs show a level of craftsmanship that seems impossible for the tools and technology available at the time. Every line, corner, and decoration was carefully chiseled into solid sandstone. Modern studies reveal that the marks left by the chisels are almost identical in angle, depth, and rhythm. This uniformity is extraordinary. When a modern stonemason works for even 1 hour overhead, fatigue causes subtle changes in hand pressure and angle. Yet at Petra, there is no evidence of such variation. Every cut is precise, consistent, and deliberate. The treasury and the monastery provide the clearest examples. Columns, statues, and decorative panels are carved with symmetry that is astonishing. The treasury alone required removing thousands of cubic meters of sandstone. Each strike of the chisel appears carefully measured, as if guided by a system no longer known. The depth of the carvings, the spacing between lines, and the angles of corners are so consistent that experts agree it should be impossible to achieve with bronze tools alone. Bronze was the main material available to the Nabotans, and it dulls quickly. Maintaining such precision over years of work is extraordinary. Researchers and engineers have tried to understand how this was done. Some suggest geometric projection methods. This involves using simple shapes, measuring tools and angles to ensure proportional accuracy. However, there is no evidence that Nabotans had these techniques. Another theory proposes wooden templates or stone stabilizers. Such tools could have helped guide the chisels and maintain uniformity. Yet, archaeologists have found no remnants of these tools at the site. There is no record of scaffolding, templates, or supports that could explain the results. Italian stone carvers who have examined the treasury's facades confirm the level of skill is impossible to replicate without modern machinery. They point out that every chisel strike, every carved edge, and every decorative relief shows consistency that even today would require lasers, mechanical guides, and industrial cutting machines. Despite these conclusions, the work was done entirely by human hands 2,000 years ago, with no machinery, no cranes, and no detailed blueprints. The paradox becomes even more remarkable when considering how the structures were carved. The treasury, like many other monuments, was carved from the top down. Artisans had to work on ledges high above the canyon floor, cutting downward into the rock. This means they could never step back to view their work in full. Modern architects rely on drones, cameras, or computer models to maintain accuracy in tall structures. The Nabotans achieved perfect symmetry without any of these tools. Every element of the facade aligns precisely with every other, as if measured by invisible instruments. Even minor features are carved to perfection. Figures, flowers, columns, and decorative motifs are not only proportional, but perfectly aligned across entire walls. This suggests that the builders had advanced knowledge of mathematics, proportion, and spatial design. Some researchers note the presence of the golden ratio and 3:2 ratios, which would have required careful planning before any carving began. Yet no inscriptions, instructions, or markings indicate how the Naboteans achieved this. The mystery remains. How could humans achieve this level of accuracy 2,000 years ago? And why has no similar precision been found elsewhere in the region at that time? If the precision in Petra's stonework is unexplained, could there be a connection to something equally mysterious, hidden inside the structures themselves? The acoustic mystery. Petra is not only a marvel of stone carving, but it also holds a mystery in sound. Inside its tombs and monuments, voices behave in unusual ways. When someone speaks, the sound does not echo normally. It does not bounce chaotically. Instead, it lingers, seems to float, amplifies in certain directions, and disappears in ways that seem unnatural. This acoustic effect is present in several chambers, especially in the end tomb where a simple whisper from the rear wall can be heard clearly at the front portico. Visitors often stumble upon this effect by accident and describe it as magical. Modern engineers compare this phenomenon with amphitheaters and concert halls. Achieving perfect acoustics in these spaces requires careful construction. Architects must calculate angles, wall shapes, and surfaces to reflect and absorb sound correctly. Usually such spaces are added with materials and shapes to improve sound. Petra is different. Its chambers were carved from solid rock, meaning the effect comes from removing material, not adding it. This makes the acoustic performance even more remarkable. The chambers are shaped precisely to guide sound. Wall angles, chamber size, surface texture, and stone density all influence how sound moves. In Petra, these parameters were apparently calculated before carving began. Yet no records, notes, or plans have been found to explain the design. Researchers believe the builders may have understood acoustic principles intuitively or through methods that are no longer known. Some suggest the use of vibrating plates or rudimentary resonance tests where sand or liquid is used to detect sound patterns. However, there is no evidence that the Nabotans employed such techniques. The end tomb provides one of the clearest examples. A person standing near the rear wall can speak softly, and the voice carries with clarity and amplification across the entire front portico. The sound seems suspended for a moment, then fades perfectly. No modern sound system or chamber design today could achieve this effect by carving alone. This suggests the Nabotans had a precise understanding of how sound interacts with stone, even without visual measurements or scientific instruments. The implications of these acoustic effects are significant. Sound may have played an important role in ceremonies, public speeches, or rituals. Amplifying voices in large spaces could have made religious chants, commands, or storytelling more effective. Yet, there is no inscription, record, or guide explaining why these acoustic designs were implemented. It appears deliberate, intentional, and astonishingly advanced for its time. The combination of perfectly carved stonework and precise acoustics creates a mystery that challenges everything known about ancient engineering. The builders of Petra did not just carve rock, they shaped it in ways that affected sight, sound, and experience. Each chamber and tomb reflects thought and skill far beyond what we would expect from a desert city 2,000 years ago. Petra's hidden sound design is a clue that the city's builders may have understood principles lost to history. The question remains, if they could manipulate stone and sound with such mastery, could there be other secrets hidden inside the city that are equally advanced, waiting to be discovered? Petra not only hides acoustic secrets, but also harbors a complex water system that seems decades ahead of its time. How did the Naboteans master water engineering in a desert? The advanced water engineering? Petra's survival in the harsh desert environment of Jordan is a testament not only to its artistry, but also to its extraordinary engineering. The region receives less than 4 inches of rain per year. Sand, wind, and heat dominate the landscape. In such conditions, sustaining a city for thousands of people seems impossible. Yet, Petra thrived, complete with gardens, fountains, pools, and ceremonial baths. The secret lay in the Naboteans' mastery of water management, a system so advanced that modern engineers still struggle to replicate it. The water system begins with cliffside channels. Small grooves and stone cuts run along canyon walls, guiding water carefully through the city. At first glance, these channels appear natural, formed by erosion. But closer inspection reveals careful design. Each channel is carved with precise angles to maintain flow without overflow or stagnation. Water collected from rare rainfall, mountain springs, and seasonal floods was directed into these channels. From there, it entered subterranean cisterns, large storage chambers carved into solid rock. These cisterns provided a steady water supply even during the driest months. In addition to the cisterns, the Nabotans developed ceramic pipelines. These pipes were connected with careful joints and lined with waterproof plaster to prevent leaks. Pressure regulators and silt traps were incorporated into the system, ensuring water moved smoothly over long distances and remained clean. The channels, cisterns, and pipelines worked together to maintain a constant flow, an impressive achievement considering the uneven desert terrain. One of the most remarkable features is the aqueduct that runs for 7 kilometers while dropping only 30 meters. This small gradient allowed water to flow steadily without overflow, flooding, or stagnation. Maintaining such a gradient over this distance requires precise calculation, careful surveying, and an understanding of terrain variations that modern engineers would struggle to achieve without digital tools. Even more astonishing are sections of the aqueduct that cut through solid bedrock. In these areas, the channels pass along unseen fault lines and difficult geological formations. Modern engineers would first create test tunnels or perform seismic surveys to ensure stability. The Nabotans, however, left no evidence of trial tunnels or false cuts. Every channel connects perfectly with the next, following the natural contours of the rock and adjusting for underground faults. Some researchers suggest that the Nabotans may have used inherited knowledge or geo-intuitive skills to locate fault lines and water-bearing layers. They may have listened to the sound of water underground or observed natural patterns in the terrain. Whatever method they used, it was effective, precise, and far ahead of its time. Petra's water system allowed the city to support tens of thousands of residents, maintain public fountains, and irrigate gardens in a desert that would otherwise be uninhabitable. The precision of the aqueduct drops, the smooth flow over 7 kilometers, and the careful routing through solid rock demonstrate knowledge far beyond what is expected for the time. Even with this incredible water management system, Petra faced another challenge: earthquakes. The city sits near one of the most seismically active regions in the Middle East. Many other ancient cities collapsed under similar conditions. Yet Petra's structures have survived for over 2,000 years. How did its buildings withstand the forces that destroyed other settlements? Could the methods used to carve stone and control water also have contributed to the city's resilience? Earthquake-proof design. Petra sits in one of the most seismically active areas of the Middle East. The Dead Sea Transform Fault runs less than 60 kilometers from the city. Historical records show at least 5 major earthquakes struck the region between the 1st and 8th centuries. Such earthquakes should have caused widespread destruction, especially to monuments carved directly into sandstone cliffs. Sandstone is brittle and prone to fracturing under sheer forces. Yet many of Petra's monuments, including the treasury, the monastery, and royal tombs, remain standing today. The question is clear: how did these structures survive where others fell? Detailed studies reveal that Petra's buildings include advanced stress dissipation techniques. Cracks in the sandstone often stop abruptly at carved transitions or edges. Rather than continuing through the stone and weakening the structure, these breaks act like shock absorbers. Energy from the seismic waves is dissipated along these transitions, preventing catastrophic failure. In addition to carved transitions, some corners of monuments are slightly detached from the main cliff face, floating by a few millimeters. These small gaps allow the stone to move slightly during an earthquake without cracking. Such features are subtle, invisible to casual observers, but they contribute significantly to structural stability. Ground-penetrating radar scans have revealed hollow chambers behind some facades. These chambers reduce the mass of the stone facing and lower seismic load. This is similar in principle to hollow core construction used in modern skyscrapers. By carving voids behind the exterior, the builders effectively reduce stress without weakening the structure. Vertical fluting on columns and recessed reliefs also plays a role. The increased surface area reduces resonance during shaking, dispersing vibrations naturally. This passive vibration dampening is remarkable considering formal studies of such concepts did not appear until the 20th century. One of the most surprising discoveries is that these earthquake-resistant techniques are not consistent across all of Petra. Later Nabotan and Roman structures lack these sophisticated features. Columns in later buildings toppled, walls cracked, and facades collapsed under seismic stress. The advanced engineering appears concentrated only in the oldest, most refined monuments, including the treasury, monastery, and select royal tombs. These structures demonstrate a level of understanding of material behavior and seismic forces that seems far ahead of their time. The methods used at Petra suggest that the builders may have inherited knowledge from earlier generations or possibly from another even older culture already adapted to this fault zone. There is no written record explaining these techniques. The precision and foresight required to design structures that can dissipate earthquake energy, maintain alignment, and survive centuries of tremors without reinforcement is extraordinary. Each monument shows careful planning, deep understanding of rock behavior, and awareness of local seismic risks. The combination of floating corners, hollow chambers, carved transitions, and fluted columns indicates that the Nabotans were not only artists, but engineers of remarkable insight. Their approach integrated natural forces into the design, turning what would have been weaknesses into strengths. Modern engineering studies confirm that these methods are highly effective. In Petra, earthquakes that destroyed nearby settlements and later constructions caused minimal damage to these carefully carved monuments. Despite this extraordinary achievement, a new mystery emerges. If the builders could carve with such precision, control water, and construct earthquake-resistant facades, how did they handle the enormous volume of stone that had to be removed? The treasury alone required removing thousands of cubic meters of sandstone. Where did all this material go? Even with extraordinary earthquake-proof design, Petra still conceals another enigma. If the builders achieved such resilience, where did the enormous amount of carved sandstone go? Could there be a lost system of stone disposal? The vanishing stone. The scale of Petra's construction is staggering. The treasury alone required removing approximately 8,500 cubic meters of solid sandstone. To put this in perspective, that is enough stone to fill 3 Olympic swimming pools. Yet, anyone visiting the site notices a strange absence. There is no massive spoil heap nearby. No quarry or mound matches the sandstone's composition and color. This is unusual because in ancient construction sites around the world, discarded rock is left behind in enormous piles. In Egypt, for example, quarries near Aswan are littered with broken chisels and debris. In Greece, stone blocks and discarded pieces remain near temples. At Petra, the largest and most refined monuments are mysteriously clean. Geologists and archaeologists have studied the surrounding terrain to trace where the removed stone might have gone. Some spoil mounds east of the city have been identified, but none match the material of the treasury or other major monuments. This leads to the question, did the Nabotans repurpose the stone, crush it for cement, or transport it far away? Each of these explanations presents challenges. The volume of stone does not match any known repurposing within Petra. Large-scale cement production remains unsupported by archaeological evidence. Transporting thousands of cubic meters of sandstone over desert terrain without modern vehicles or cranes would have been an enormous logistical undertaking. Interestingly, the anomaly is selective. Later monuments, those built after the treasury and monastery, contain visible debris, chiseling waste, fragments, and abandoned cuts appear around newer structures. Only the earliest, most sophisticated facades are clean. This pattern suggests careful planning, deliberate management, or advanced knowledge of construction logistics. Removing stone in a precise and organized way would require coordination far beyond what we expect for a desert city 2,000 years ago. Some researchers proposed that the process of carving and stone removal took place over generations. Teams may have worked in stages, carefully moving and storing the stone. The absence of debris implies not only skilled workers, but also project managers who understood material handling at a scale unexpected for the period. Others suggest that part of the removed rock may have been used in ways we have yet to uncover, possibly in underground chambers, hydraulic systems, or foundations. Regardless, the meticulous organization required points to a civilization capable of remarkable planning. The clean facades of the treasury, monastery, and royal tombs emphasize the contrast with other ancient sites. The Nabotans appear to have mastered a system that combined precision carving with debris control. They were able to remove thousands of cubic meters of rock without leaving evidence, a task that even modern construction crews would find difficult. This vanishing stone remains one of Petra's greatest mysteries, raising questions about lost techniques, advanced project coordination, and possibly knowledge that has been forgotten over time. Petra's stone, water, and structural stability appear to be perfectly aligned. Yet, the city may hide even older secrets beneath the visible monuments in the cliffs, cisterns, and chambers. Could there be knowledge or structures that predate the Nabotans themselves? Petra's hidden origins. Petra is often credited as the masterpiece of the Nabotans, but careful study of its oldest structures suggests the story may be more complicated. Recent investigations point to evidence that a civilization may have existed in this area over 1,000 years before the Nabotans carved their monuments. One of the most striking discoveries comes from beneath the treasury's polished surface. Using advanced imaging techniques, archaeologists have detected faint tool markings invisible to the naked eye. These marks are not random. They resemble Proto-Sinaic script, a writing system that predates Nabotean inscriptions by over 1,000 years. Their presence indicates that work on the cliffs may have started long before the city is traditionally believed to have existed. Architectural motifs further complicate the picture. Certain flourishes on the treasury and monastery, including Hellenistic columns, Assyrian-style reliefs, and geometric designs do not appear elsewhere in Nabatian culture. The Nabotans were highly skilled traders and architects. Yet these features suggest knowledge inherited from an earlier culture with influences from distant regions. The precision of these motifs combined with other anomalies hints at a level of engineering sophistication unmatched in their recorded history. Adding to the mystery, magnetic surveys conducted across Petra reveal unusual patterns. Compasses deflect by as much as 6 degrees near certain columns, niches, and carved voids. These anomalies are localized, meaning they do not occur randomly across the sandstone, but concentrate near the most precise and intricate structures. Geophysicists are puzzled because core samples from these areas show no concentrations of magnetic minerals. This has led to speculation that the builders of Petra may have experimented with early forms of magnetism or some type of energy manipulation unknown to modern science. Such knowledge would provide an explanation for the deliberate alignment of certain features and the consistency and measurement observed across the largest monuments. Ground-penetrating radar adds another layer to the story. Subsurface scans have revealed chambers and voids buried beneath the city that align with magnetic gradients. These chambers are not randomly placed. They follow a consistent orientation that appears deliberate. Their purpose is unclear, but the alignment suggests understanding of natural magnetic forces and perhaps even celestial observation. If these chambers predate the Nabotans, it would explain why later builders could achieve feats such as precise carving, seismic resistance, and acoustically perfect chambers. They may have inherited a foundation of knowledge already refined by a lost civilization. The implications of these discoveries are profound. If Petra's earliest monuments were influenced by a civilization unknown to history, then much of what we attribute to Nabotan ingenuity may actually be a continuation or adaptation of older techniques. This could explain the seemingly impossible feats of engineering. Top-down carving with perfect symmetry, complex water systems, earthquake-resistant design, and hidden acoustic features. Each of these achievements becomes slightly less mysterious if they are built upon knowledge passed down from an earlier culture with expertise now lost to time. Despite these clues, definitive evidence remains elusive. No inscriptions confirm the existence of this pre-Nabatian civilization, and no tools or artifacts have been definitively linked to it. Yet the physical traces, the proto-Cetic markings, unusual motifs, magnetic anomalies, and aligned subterranean chambers paint a compelling picture. Petra may have been the inheritor of a forgotten technological tradition, a city built not solely by the Nabotans, but upon centuries of experimentation and engineering passed through generations. If Petra hides evidence of a forgotten civilization, what does its legacy tell us about the limits of human ingenuity? And how can we explain it today? Petra's legacy. Petra stands as one of the most extraordinary achievements in human history. Its massive facades carved directly from sandstone cliffs are precise to within 20 millimeters. Its chambers produce sound that lingers and amplifies, defying expectations of ancient acoustics. Water channels, cisterns, pipelines, and pressure regulators supply a thriving city in one of the driest deserts on Earth. Earthquake-resistant design allows monuments to survive tremors that destroyed other settlements. Yet, the mysteries continue. Thousands of cubic meters of sandstone have vanished, leaving no visible spoil heaps. Magnetic anomalies and possible pre-Nabataean markings hint at knowledge older than the Nabotans themselves. The convergence of these features is remarkable. Stonework, water systems, structural engineering, and acoustics all reflect extraordinary precision. Modern engineers struggle to replicate even one of these achievements using contemporary tools. Petra is not only a city, but a puzzle. Its creators mastered forces of nature, materials, and mathematics far beyond what was thought possible at the time. Each monument reflects an understanding of geometry, physics, and resource management that challenges our assumptions about ancient civilizations. The silence of inscriptions adds to the enigma. Unlike other ancient cities, Petra's most massive monuments are almost entirely unrecorded. While thousands of smaller inscriptions exist across the city, major constructions such as the treasury, monastery, and royal tombs lack dedications, records, or explanations. This absence leaves behind only questions. Who commissioned these structures? What was their intended purpose? Were they built as ceremonial sites, practical monuments, or something entirely different? Petra's legacy is therefore twofold. First, it demonstrates the heights of human craftsmanship and ingenuity. Even without modern machinery, tools, or written guidance, the city reflects extraordinary vision and execution. Second, it represents lost knowledge. The methods used to carve stone with millimeter precision, manipulate acoustics, manage water in a desert, and resist earthquakes appear forgotten. Later, Nabotans and Roman constructions failed to replicate these features, showing that once the knowledge was lost, it could not easily be recreated. Modern researchers continue to study Petra using advanced technologies. Photogrammetry captures the most precise measurements of facades. Ground-penetrating radar scans reveal hidden chambers and possible construction techniques. Magnetic surveys highlight unexplained anomalies. Each new study uncovers more details while deepening the mysteries. Petra remains a living laboratory for scientists, engineers, and historians, inviting ongoing exploration. The enduring fascination with Petra is not only due to its beauty, but also its unsolved puzzles. Every wall, channel, and carved chamber holds secrets that challenge our understanding of ancient human capabilities. From precise carving to earthquake-proof structures, from vanished stone to hidden origins, Petra is a reminder that history may still contain knowledge we have yet to comprehend. Petra remains one of the most incredible achievements of human history. Its massive facades, carved directly from sandstone cliffs, showcase precision that rivals modern technology. The city's water systems, earthquake-resistant design, and acoustic chambers reveal an understanding of engineering, physics, and mathematics far beyond what was expected for its time. Even today, modern engineers, archaeologists, and scientists cannot fully explain Petra's methods. It remains a city of secrets, a testament to lost knowledge and the extraordinary creativity of those who came before. Petra is not just a place. It is proof that human potential can stretch far beyond the limits we imagine, waiting for discovery and understanding. If you enjoyed this video, like and subscribe, and also click the next video shown on your